we have two readings, which are kind of theory or factoid based, so as to say, machine learning and big data. Now, at level 2 curriculum, what they've tried to do is, so here's what I think CFA Institute wants. What CFA Institute wants is that you're an analyst, probably doing equity research, and there are some quant guys, in your team, maybe your colleagues, and these quant guys are, discussing some of the machine learning stuff, near let's say a water cooler conversation, and you happen to be there, and they know that you are, a CFA charter holder or a CFA candidate, and those guys are not. Maybe they are just computer guys, and they're talking about, some fancy machine learning technique, let's say lasso. So CFA Institute do not want you to look like dumb there, right? That's what they want to achieve with this study. This is what I honestly feel, that if two people are trying to have an intelligent conversation and you just happen to be there, you should not be like that. I don't know if you guys watch Friends. There's this particular show I remember of Joey, where he tries to buy that encyclopedia. I don't know if you've ever seen that. Yeah, right. Vivisection. Yeah, yes, perfect. So this is exactly what Institute has tried to do. Now, my challenge as a teacher is that I do not, as I said, I don't have practical experience in this, and I honestly believe that in order to be able to teach something, you should have the skill to simplify it. Now, since I don't have experience, I'm trying to compensate that by doing a lot of reading online, and then talking to people who I know who work in this space. That's why my speed of learning this is a little low. I'm just trying to be comprehensive. But what I'm trying to do is, once I understand something, I'm trying to put that in a very simplified fashion. And that's what I've tried to do in my presentation today. So let's see if that works for us. So while doing my research, I came across this brilliant joke online. So I thought this would be a great, the beauty with this joke is it also summarizes what we are going to do with, with this entire machine learning exercise. So let's read this together. This guy says, this is your machine learning system. I says, yeah, put in the data, this big pile of linear algebra, then collect the answers on the other side. And he says, what if the answers are wrong? And he says, just stir the pile until they start looking right. But this is more or less, what we're going to learn, in this section. This is going to be like a very broader way of looking at machine learning. So I looked at a lot of definitions, including what definition we have within the CFA curriculum. And I thought that how can we think of machine learning in a very, very simplified way. So this is how I think of it now, that we have some data, and this data might be, a huge chunk of non-linear data. For example, behavior, the average time spent by an individual on social media and which all sites he visits, and maybe we have that kind of data. And let's say there's huge amount of data with multiple dimensions and a lot of non-linearity. The whole idea with machine learning is to try and build some sort of a pattern within the data set. Now, either could be a pattern of relationship, it could be a pattern of clustering. We'll learn all those patterns eventually. And once you have been able to establish the pattern on the data that's available, the empirical data or the historical data, then you want to exploit that relationship to make some decisions. Okay, so that's how we're going to think of this broadly. And then, the question that came to my mind when I started thinking like that is that, isn't that the same thing that we do in statistics? For example, sometime back, we were learning regression, right? And when we were learning regression, we kind of did the same thing. We did the same thing, didn't we? That we had data points and we were trying to build some sort of a relationship between the two. So the answer is that what's the difference between machine learning, so as to say, and the basic plain vanilla statistics that we've been learning in school or in the grad courses is, number one, the big difference is that machine learning gives you opportunity to deal with complex set of data. So I said earlier that regression works when the data points are linear. But what if you're dealing with non-linear data? What if you're dealing with data which has multiple dimensions to it? Now, what do I mean by multiple dimensions? So in the regression example, in one of the example, we tried to explain return on a stock with returns on market. But what if we try to explain return on stock with return on market, GDP, interest rate, exchange rate, fiscal deficit, current account deficit, reserve ratio, debt to GDP ratio? So we can have thousands of variables which define the reason why stock prices move. So if you have complex set of data, machine learning is better suited. Then if you have an evolving data set where your data set is continuously changing and you want your algorithms to capture that evolving behavior, then machine learning works. If you have non-linear data, machine learning works. So these are primary differences, broadly speaking, that distinguishes uh, machine learning from the traditional statistics. And of course, another thing that I came across, though your curriculum doesn't say that explicitly, is terminology. Okay, so the same concept, but in machine learning world, we give it different names. For example, sometime back when we discussed regression in the class, we discussed that there are two variables in a simple regression, x variable and y variable. Now, what did we call x variable? X variable was called what? The x variable was the independent variable, right? And y variable was called what? Correct, the dependent variable. Now, in some of the machine learning technique, we would be using x and y variables again, but we would just change their names. For example, going forward, I would not be calling this as an independent variable in machine learning classes. We would simply be calling this as, does anyone know? We would simply be calling this as, correct Hardik, features. We would simply be calling this as feature, and this we would simply be calling as target. Okay, but same concept, but just different nomenclature that gets applied in the machine learning world. So your x variable becomes a feature here, and your y variable becomes a target. Okay, so that's a very broad way of looking at the differences between the two. Now, while doing some research, I came across some very interesting articles, right? So what I wanted to do is I wanted to look at some examples where machine learning or artificial intelligence have proven to be useful. And I think the internet is filled with examples, thousands of them. But I picked up a few of them, which I thought were really interesting. So this is the first example that I came across. The headline here, it says that Delhi police has reunited 2930 missing children with their families in 5 days. And how were they able to do it? So it's interesting that how the government was able to leverage on some of the machine learning technologies to solve real life problems. So when I was digging through this article, I came across this particular website of Government of India. It's called connectmissingchild.com or something like that. If you Google, you would find it easily. They also have an Android app called Khoya Paya. Khoya is lost in Hindi and Paya is found in Hindi. So they have an Android app which does that. And what this website essentially does is that if there is a missing child, then people who found missing child are supposed to upload their information there, and people who lost their children for whatever reason are supposed to upload their information. Now we know in that certain part of our country, it's kind of an this practice is very rampant, where people would take away these children of workers, and therefore we have a lot of cases of lost children in India. And what government did is it used a facial recognition software because they had several 100,000 of these images on their website on both the sites. And it was impossible for them to match them on one-on-one basis. So what government did is they used a facial recognition software to connect the two sites. And that's how within 5 days, they were able to solve those 2,900 odd cases. Right. So that for me is a phenomenal use of this technology in practice. Now, this technology, especially in our industry, has also been applied tremendously in a lot of different areas. So we have a lot of hedge funds which make use of machine learning and artificial intelligence technology. Now, one particular thing that I found extremely interesting is this sentiment analysis or this text analysis. Okay, so there has been a lot of research done on reading the description in 10K and 10Q, especially the management discussion and analysis, right? So in FRA classes, we've learned there's something called as management discussion and analysis. What these softwares would do is these softwares would take the text which is there, and then it would analyze the text depending on the tone of the language. And based on the tone of the language, and the specific usage of the word by the management, the software has been able to predict what would be the returns on the equity on that particular stock over a period of time. And again, that's phenomenal. So while I was searching on this, I came across multiple research papers online, which were available free of cost, where there were some research papers which questioned the quality of some of these softwares. And then there were some research papers which were able to prove that this type of technique works. So this was one paper. Now I just put in some screenshots of the headings. So in case this excites you, it becomes easier for you to go and search for them. So analysis of speculative language in 10K filings. There was another very interesting one, the pessimism factor, 10K textual analysis and stock returns. And then there is a trend model on SEC filings for financial natural language in task. Right? So many of these examples are available. And then this is a curriculum. This is a line that I found in curriculum, which I thought was interesting, which says the research suggests that machine learning solutions outperform the mean variance optimization in portfolio construction. Do you remember who did this work? So Professor Harry Markowitz in 1950s and 1960s, he built this whole concept of efficient frontier and mean variance optimization. So what now the new research suggests is that if you use the machine learning tools, you might be able to do better than what you did in a traditional format or traditional section. And in a way, it's a good news and bad news both. It's a great news for investors because after reasonable trials, we would have a better technique to work with the portfolio. But it's a bad news for a lot of people like you and me, because then our skill sets, kind of become redundant because we know that machines can do better job than what we are doing right now. Okay, so moving further. These are 3 high value sentences that I came across in curriculum. We're going to go through them. Machine learning seeks to extract knowledge from large amount of data with no statistical restrictions. Now, what do you mean by that? So try to remember some of your basic level 1 quant classes. If you remember, we used to discuss normal distribution, non-normal distribution, chi-square distribution, F distribution. And only if a certain data follows normal distribution, then you can do this analysis or you can do that analysis. There is no such requirement with machine learning. It doesn't matter what kind of distribution the data follows. It does not have to be a predefined distribution. No matter what data you have, you can still apply machine learning on them. So from an exam perspective, this would be an important point. There could easily be a theory question which says that is it necessary to have a normal distribution or a chi-square or F? The answer is clearly a no. Second, the goal of machine learning algorithms is to automate decision-making process by generalizing from known examples to determine the underlying structure in the data. This will make a lot more sense once I do a few examples with you. Machine learning techniques are better able than statistical approaches to handle problems with many variables. So many variables means, especially we're dealing on the X side, right? So features. We have many features, many explanatory variables or independent variables, which we would typically call as high dimensionality. So slowly, we will have to get ourselves acquainted with this machine learning world language. So many variables, we would call this as high dimensionality or with high degree of non-linearity. So in terms of the total horizon that we have, at what sections we have within the machine learning world. So what we have is something called as supervised learning. Then we have the unsupervised learning. And then we have deep learning. Okay, so these are the three broad ways in which curriculum divides the entire machine learning exercises. Now, in today's session, what we're going to do is we're going to get through with the first two sections here. So hopefully by the end of the session, all of us will have a good idea on what supervised learning is and unsupervised learning is. So let's get on with supervised learning first. Now in supervised learning, are we all together? Okay. All right. Now, all your questions you can ask me once I'm finished, but just try and focus there. Okay. So what's happening in a supervised learning in a very broad way? You have two variables here. So you clearly have this X variable and Y variable, how we had that in regression. What is X variable? X variable is the independent variable. But in the machine learning world, we will not call it independent, though it's the same thing, Shubham. In the machine learning world, the language that we use is, we're going to call this as feature. And Y variable is going to be called as a target. The dependent variable, this is what we call as target. So we have a X variable and Y variable together. Now, we as data scientists, we already know what is X, what is Y. And let's say an example. An example would be the number of hours you're studying for CFA level 2 exam, and Y variables is your score on the exam, right? So now this is X, this is Y. What we can do is we can take historical data of, let's say, 10,000 CFA candidates and give that to our computer, and we can say, we can give it to machine and we can say, see, this is our labeled data. What do you mean by labeled? I'm specifically telling you that this is X and this is Y. This is my feature, this is my target. And when someone studies for 200 hours, it does not pass the CFA exam. But when someone is studied for 500 hours, it seems he has passed the exam. And then what your machine does is your machine kind of learns that relationship by carefully observing historical data. And once it has learned that relationship, then it can apply that to out of sample data. For example, now, for example, you come to me and you say, Utkarsh, I am planning that I would be studying for 370 hours for level 2 exam. Do you think I would pass? And then I would simply go to my machine and I would ask that question. And based on what relationship it has been able to build, it will tell you whether you would pass or you would not pass, right? It's that simple. So that is your supervised learning. So why is it called supervised learning? Is because the way I think of supervised learning is that here we humans are able to teach or supervise the behavior of the machine. So we are able to teach them. We are able to tell them that, see, this is X, this is Y. I know the relationship between them. I know that when someone studies more, they have a better chance of passing. This is the data. You look at, I'm specifically telling you this is X, this is Y. X defines Y. Now you learn the relationship and let me use it for future. Okay. So what could be other examples here? So a great example which is given in the CFA curriculum is that what you do is you give your machine the credit card transaction features. What could be features? So let us say a feature would be an average amount of credit card transaction, the device from which credit card transaction is used, the geography where money is being spent, the geography from where the money is being spent, right? The location of the service provider, the location of the customer. So provide all the details. And then you provide that whether in the past this particular transaction was fraudulent or not, whether it was a genuine transaction, not a genuine transaction. So what your algorithm will do now, it has all the historical data, and you have yourself taught the machine that, see, this in this instance this was a fraud transaction, in this instance it was a genuine transaction. And then your machine quickly learns that some user who resides in Mumbai, and suddenly when the credit card transaction is initiated from some place in, let's say, some place in Russia, I'm just taking a random place, then maybe it's a red flag, maybe something is wrong, and your machine learns that quickly, and then in future it applies that to different transaction and tells you whether the transaction has a probability of being fraudulent or not. Have you understood this? Devote, it's a local problem, please fix it. So again, bringing you back to the main schematics of this section. Right now, what we are learning is we've just learned what supervised learning is. And the moment I say supervised, one word should come to your mind. Tell me, what word is that going to be? The moment I say supervised learning, there should be a word that should come to your mind. That is labeled data. Correct. Labeled data. We are providing historical information to the machine, and we're telling them, see, this is the relationship in the past. You learn from it, and then you apply it in future. So you should not say historical data. Say labeled data. Labeled is important. What is X? What is Y? We're able to define that. So that's the labeling of the data. So within supervised learning, there could be two scenarios or two types of problems that we can solve. So first problem that we can solve within supervised learning is a regression problem. And second is the classification problem. Now, this regression word here does not have anything directly to do with the linear regression that we've been learning. It's just a machine learning language. So here, we'll just say that supervised learning has two types, regression and classification. These are the two categories. Now, when do you use a regression mechanism within the supervised algorithm? So when your target variable is continuous. When your target variable is continuous. And when would you use a classification problem or classification mechanism when your target variable is some sort of a category or it is an ordinal variable? Now, what could be a continuous variable? So historical market return, okay, or return on a particular stock. Now, why is it a continuous variable? Because we can have infinite combinations of, infinite numbers of return. For example, you can have 9%, or you can have 9.00001%, or you can have 9.002%. We can have infinite possibilities there. So then we call this as the continuous variable. Or probability of default, it can be 50% or 50.0001%. Again, infinite possibilities. So when you have a continuous variable as your target variable, what we are going to use is the regression problem. But when your target variable is a categorical or an ordinal variable. So what would be categorical variable? Simply whether a transaction is a fraudulent transaction or not. So that becomes fraud detection of credit card transactions, either yes or no. So we have two categories, a binary situation here, yes or no. Or whether a particular type of investment is, if we have to categorize that between a good, bad, ugly type of investment, then it becomes an ordinal variable. So if you remember in CFA level 1, we had different data scale measurements, right? We had nominal, and then we had ordinal, and then we had ratio, and which was the last one? We had nominal, ordinal, we had ratio, and then, okay, we had one in between called interval, right? Different different scales, different types of data or measurement scales. So a categorical is nothing but your nominal data point. Nominal means you just, classifying it based on some sort of a predetermined category. And ordinal would be where you're giving them some sort of a sequence. Something is higher, something is lower. There's an order to it, but it's not easy for you to quantify the difference between the order. So credit rating is a great example. Ranking is a great example. So these are all ordinal data points. So whenever you're dealing with a target variable, which is ordinal or nominal, you use a classification mechanism of supervised machine learning. Whenever you have a continuous variable, you use target. Okay, that's what your curriculum has. Of course, later on, we have a little more details on how these work. Okay, right now, this is what we need to know, that within the machine learning space, there are three categories that we're going to look at, three broad categories. Tell me which ones. Within the machine learning space, three categories that we're going to look at. Which ones? Supervised, unsupervised, and then deep learning. Now, when do we know that we're dealing with supervised learning? Like in what situation we know that we're dealing with supervised machine learning category? When your data is clearly labeled, which means you know what is the feature and what is the target variable. Now within supervised, if my target variable is continuous variable, then we're going to define that as a regression problem. If it is a ordinal variable, then we're going to define this as a classification problem. Good. Now let's build on to this a little bit more. Next section is unsupervised learning. Clearly, the big feature that we need to know here is that the data is not labeled. So we don't know what is a feature, what is a target. Everything there becomes a feature. Everything is nothing is, X is not defining Y because you don't know what the Y is. Now in unsupervised learning, we have input X that are used for analysis without any target Y being supplied. So target Y is not available. Everything is X. Because ML algorithm is not given, algorithm seeks to discover structure within the data themselves. And this is where it is unsupervised learning is incredible. Now, my thinking on this is like that. So I would like to think of myself as a student of, the markets, and as a student of the market, as an investor, I would like to learn, different characteristics about a stock that results into extraordinary return. So if you'd ask me, Utkarsh, what are those characteristics? I will tell you maybe a business having significant moat, having good quality management, industry tailwinds, all of these will result into excellent returns. So if I know that a good moat, a strong moat or a wide moat for a business, or excellent industry characteristics results into good returns. If I know that, then I'm essentially dealing with a supervised machine learning algorithm. But I'm sure there are a lot of things that I, as an investor, do not know in terms of what drives the markets. So what I go to is, I go to the machine and I tell them, see, these are all the data points that we have. I just dump in all the data. You figure out what is the relationship, right? You try to build that relationship with each other. And when the machine itself discovers that relationship, then that becomes an unsupervised learning. So which means in the supervised learning, the human is teaching the machine, In the unsupervised learning, at least that's how I approach this. The machine is teaching the human. Let's see, this is your data point, and what I would like to tell you is that the companies in typically this sector tend to do better than this sector. Are you following what I'm trying to say? So now, unsupervised learning. Next 10 minutes are very important, and then we kind of done for the session. But you're going to enjoy this, trust me. This is like phenomenal concept. So in unsupervised learning, we primarily use it for two types of problems. One is dimension reduction, which sounds really fancy, when we try to kind of read through this section. And the second one is clustering. So after a lot of time of researching this, what I really understood about dimension reduction is this is similar to in traditional statistics, what we use as, or even engineering students might have learned, something called as principal component analysis. Right? So it's kind of the same thing, but there's an easy way to conceptualize this. So I've written this nice example. So what's happening here is we have a character called Pappu who has not passed the exams. So Pappu did not pass the exams, and we're trying to figure out the rules of why Pappu did not pass the exam. Okay. So these are all the reasons why he's not passed the exams. So first reason is he's dumb. Second is he did not study. Third is he missed his classes. He has low IQ. He forgot his calculator on the day of exam. He forgot formulas on the day of exam. He did not read the questions carefully. All these reasons contributed to Pappu not passing the exam. What you want to do in dimension reduction is essentially you want to get rid of these unnecessary features. Your data has multiple dimensions. You want to reduce those dimensions as much as possible. So if you'd observe carefully, what I've tried to do is I've said these two first reasons kind of summarize everything else, right? That's a very loose way of looking at dimension reduction. For example, Pappu is dumb. That automatically tells you that he's the one with low IQ. So when I say he's low IQ, he being dumb gets captured there. He forgot his calculator on the day of exam. Definitely, he fits in this category. He did not read the question carefully. He fits in this category. Then he did not study. Automatically indicates he missed his classes or he forgot formulas because he did not put in enough time. So what it basically means is it means you have too many dimensions to your data set, and what you want to do is you want to retain that explanatory relationship as much as possible, but at the same time you want to get rid of all the extra features that lie within the data set. Okay, so this is the technique that typically works in dimension reduction. Have you understood what's happening here? Okay. So one sentence from the curriculum. Reducing the number of features. Features means which variable? Features is the X variable or the independent variable, while retaining the variation across observations to preserve the information contained in that variation. So we want to reduce the number of features, but we still want to retain important information. That's what you have under the dimension reduction technique. Again, don't lose the big picture. We are under unsupervised learning. And the second category of unsupervised learning is clustering. So now I go to my database, I go to my machine, and I give it a lot of information. For example, I give returns of all the stocks within financial space. So we have, we have these stocks where you've made within the financial space, some stocks where you've made money, some stocks where you've lost money. And then we give IT stocks, and then we give pharma stocks, and we give cement stocks. Now, typically, as an analyst or industry defines the stocks based on industry they belong to, and we dump in all the data into the machine, and the machine does not know what classification is what, so it classifies the data based on the empirical observation, empirical behavior. And what machine will do is machine will say, okay, I don't understand what cement or pharma is, but we can simplify, cluster the data like this. We can have the data which we can have all the stocks that make money for you and all the stocks that don't make money. Right? That could be an example of clustering the data. So you pump in a lot of data into it, and what machine will do is it will observe the empirical relationship and it will cluster the data with each other, even though that data on the face of it might not have a meaningful economic relationship. Are you following what I'm trying to say? And what does curriculum say about this? The groups are formed based on a set of criteria that may or may not be pre-specified, right? So maybe as an analyst, you wouldn't know that these stocks are being clustered together. They're not from the same industry. They don't have the same PE ratio. Maybe they're completely different. But empirical observation shows that these stocks tend to move together. So they become one cluster of the stocks. So that is your clustering, and that is your dimension reduction technique. And then one last sentence for the day, and we kind of over, and then we will take your questions there. So clustering has been used by asset managers to sort companies into empirically determined groupings. Empirically determined means based on historical observations, based on their financial statements data, rather than conventional groupings, which is based on sectors or countries. Right? So typically, how do we look at stocks? We'll say, okay, which sector it is coming from, or which industry it is, or whether it's emerging market, non-emerging market. But maybe in clustering, we can divide all the stocks as high ROE, low P as one group. Or we can cluster the stocks based on whether the stocks are currently in momentum, a positive momentum or negative momentum. So classifying or grouping the stock based on different characteristics, that's your clustering. And with this, my today's machine learning agenda is done. A super quick revision to you. What we discussed today is what machine learning is. Then we discussed what is supervised learning, unsupervised learning. In supervised learning, the important thing for us to know was the fact that we have labeled data here. We have an X variable and a Y variable. And then there is no such labeling in unsupervised learning. Another way in which we build thought process on this is that in supervised learning, the human is teaching the machine, whereas in unsupervised learning, the machine would be teaching to the human. It will be finding patterns there. Then in supervised learning, we looked at two situations, regression and classification. Can you tell me when would you use regression? When would you use regression technique? When? Correct. When target is continuous. And you'd use classification when target is an ordinal number or some sort of a category. Then in unsupervised learning, we have dimension reduction technique and clustering technique. So in dimension reduction, we did example of that candidate or that guy who was not able to pass, and we tried to figure the reason why he was not passing with the entire list. And we said that just having those two items, like just having those two dimensions, we can get rid of everything else and still explain why it's happening. And in case of clustering, we feed the machine with a lot of data, and what machine does is it just groups the data based on their common characteristics. And that's it for the day. Now, those of you who've understood everything, it's okay to leave and come back tomorrow at the same time. And those of you who would like to stay back to listen to queries or ask queries, I'll be here for another 10 minutes. Okay. By the way, as far as PDFs is concerned, I would be sharing everything. You don't have to worry about writing it. It's just that I would prefer to share it once I've finished, because I'll be making a lot of changes to it. But you don't have to worry about it. I'll do share everything as it is. If you'd like my markings, I would share it with marking. I don't mind it. Okay, I will. Thank you very much. I will share with markings. Will clustering and dimension reduction require human intervention? I would guess not. I mean, based on how curriculum has written it. But I mean, and that's the whole idea with unsupervised learning. You let the machine learn by itself. So it wouldn't require the human interaction, so as to say, from an exam perspective. But I think in practice, of course, you would want to check what kind of algorithms are being built. But I think that question, Arpita, you should ask to someone who is practicing this, maybe a data analyst. He should be able to answer you. In unsupervised learning, we don't know why. Then how would we reduce the dimension without knowing the end result? So Bhuvneshwari, this technique, there's this technique called principal component analysis. What I would probably recommend you is, if you go on YouTube and watch some videos. It's not easy. It's very complicated. I did a video on it a long time back for one of the FRM classes. But it's a technique where you kind of retain most of the variation in the data set, but at the same time you're able to get rid of the excess X variables that you have in your data set. Okay, so maybe it's highly mathematical. I think the best way to learn it is just, I came across one very brilliant video by one professor of IIT, I forgot which one, on YouTube last time when I learned this topic. So maybe I'll recommend you go and watch that. If you search on it, you'd find it easily. Since this is a new section, would you be doing a lot of questions? So Holly, the thing is, this is all theory question, and I'm not great at writing theory quizzes. But the good news is, CFA curriculum has a lot of high quality examples. So a great idea would be, for example, now you guys have the level of knowledge where you can go and do the blue box one, the example number 1 of CFA curriculum. You should be able to answer that easily. Or do you mean on the actual CFA exam? Oh, okay. I don't know. I mean, this is by the way, it's a myth that new content gets tested heavily. CFA Institute they use statistical techniques to remove any sort of biases on the CFA exams. So what I mean by that is that they themselves keep it very random. So there is no such rule. I used to think that earlier, that it's a new topic, so it will get tested heavily. But that doesn't work all the time. I mean, they might or they may not. There's no way to tell. Does CFA use machine learning? I don't know, but I hope they would in future. In unsupervised learning, data is clustered into groups by the data itself and not by the researcher. Yes, that's correct. It's done by the machine by itself.